Okay, in this video we're going to look at a shape called a hyperbola, the simplest of which has equation y equals 1 over x. So we might get ourselves a few points to start with again, only this time we can't start with x equals 0, because you can't divide by 0. So the curve will never actually touch the y-axis, but more on this later. We might start with x equals 1 then, in which case y equals 1 over 1, which is 1. When x equals 2, y would be 1 over 2, or a half, and when x equals 3, y would be 1/3, and so on. Okay, the fraction will get smaller and smaller as x keeps on increasing. The interesting thing about this relationship, though, is division has a symmetry where you can swap these two, like how if 10 divided by 2 is 5, 10 divided by 5 is 2, that sort of relationship there. So that means we can actually swap around all the x and y values in those points, meaning we have points along here as well. And that is going to give us a curve looking like this. Now, I want to give you another perspective, though, that might be interesting and helpful when we look into these guys in more detail, probably in future years, and that's by simply rearranging the equation you see into xy equals 1. That just comes from multiplying both sides by x. In this case, if you look back on the graph, the x and y values are these two lengths here, the sort of length and width of that box. And actually the product xy gives you the area of the rectangle spanned by those two lengths. And so the equation insisting that xy always equals 1 just means that we want that rectangle's area to be locked at 1. And you can see that this is true as we slide across the hyperbola. If the length gets really long, the width has to sort of shrink to compensate, and we get this really flat rectangle whose area is still 1. Likewise, if the rectangle gets really tall, then it has to be really skinny as well to preserve that area of 1. Notice though that it is impossible for the length or the width to equal 0, because in that case there's just no rectangle at all. Okay, so it can't have any area, which is why both x and y are not allowed to be 0. We saw that algebraically right at the start by saying you can't divide by 0, but that's another way to see this same fact on the picture. So that's an, I guess, interpretation that might be helpful for analyzing these things further down the track. Okay, now x can of course be negative as well, and dividing 1 by a negative number just makes the whole fraction go negative, so it just flips to the other side there in very much the same way. So we meet again that same feature we saw in the last video on exponentials. The curve is getting closer and closer to the line y equals 0 here. Okay, this time in both directions. So we'd still say that dotted red line y equals 0 is an asymptote. But this time it's also getting closer and closer to this vertical wall x equals 0. Remember, there's a symmetry between x and y. Okay, so we have also a vertical asymptote at x equals 0. Okay, so those are the features of our hyperbola. Now, of course, those asymptotes can move around as well if the hyperbola gets moved, and I'm sure you'll see some examples of that later. Okay, we'll just finish by showing what happens in the equation when we change the 1 into another number, say 2 or something. Okay, so now it means that xy equals 2, not xy equals 1, and that means the area of the pink rectangle needs to be stuck at 2, not 1. And so on the picture, we just inflate that rectangle to an area of 2, and that makes the whole hyperbola puff out a bit like that. But everything else we said before still applies. If it gets super long, it still has to compensate by becoming shorter and flatter, right? To keep an area of 2. And likewise, if it gets super tall, it still has to get super skinny like that. So the shape doesn't really change. It's just like you've maybe pulled it out a little bit or something, okay? And so that means the asymptotes haven't moved. They are still x equals 0 and y equals 0 if that's all you change in the equation. Okay, again, if you start adding numbers to the end or you change x into x plus 2 or something, those asymptotes will move, but just changing that top number doesn't really mess with the shape that much. Okay, it just makes it puff out a bit or maybe shrink in a bit. Okay, so of course you can do other things like flip it and stuff, but as we said previously, we'll leave those things for you to play with yourself. Okay, so that's all for this one. Thanks for watching. See you around.